Hello, and welcome to this AI DevOps webinar with Andy Piper, where we'll be talking through the question, why improving testing capabilities with AI is so critical for DevOps. As enterprises scale their DevOps software engineering practices, there can often be many challenges, roadblocks, and hurdles that need to be navigated to deliver the best results and improve testing capabilities. Over the course of this webinar, we'll be taking a look to understand the key components of DevOps in testing, exploring the various relationships of DevOps and its inception, the current landscape of DevOps, and finally examining what the future holds for DevOps and the critical inclusion of artificial intelligence for continued scale. Andy, it's great to have you here. Before we dive into the crux of today's webinar, it'd be great if we could get a bit of a summary of your background, what brought you to Diffblue, and some of your thoughts around DevOps and why this has came to be.
Sure. Well, thank you. So I'm Andy Piper. I'm VP of Engineering at Diffblue, and my background is very much software product development. So I've led development teams. I've been involved in the development of software products, primarily middleware based in Java, for 20 years plus. So DevOps, as everybody knows, DevOps isn't a new thing. People have been trying to do software better for a long time. Always the challenge is business wants it quicker, but they don't want bugs in it, and development wants to deliver quickly, but recognizes the challenges with delivery of software. And DevOps was developed around some of the Agile practices that came around in terms of development leading to incremental delivery, and the kind of automation around that allows us to do that successfully without kind of rework and retesting. So we used to develop in a very linear fashion, come up with functional specs and design and some coding and then some more coding and some testing and some integration testing and some user testing, and we in this very linear waterfall fashion, and Agile recognized that doing things in that way meant that you stood a very real risk of ending up with a product that nobody wanted or was too late, or by the time you understood the problem, which took some development, the problem had changed or you were too far into the implementation. So we ended up with lots and lots of failed projects because by the time they wanted to turn the ship, it was all too late. So Agile kind of recognized that you needed to counter the user problems on a continuous basis as you were doing development, so that you could navigate your way through that problem and solution space. The way that Agile did that was by focusing on the important things, prioritizing things, allowing cross-functional teams to come together to deliver solutions to user problems rather than implementation of specification, effectively. So as part of that iterative, more collaborative style, where you're always trying to deliver value on an incremental basis, then became the question was, how can I deliver that value right to the end user? How can I do that incrementally? I think that's one of the reasons why DevOps has come about, that desire to incrementally deliver value all the way to the end user. Now, obviously, an end user is not going to be happy to take a kind of alpha or beta version of a product every 2 weeks. What they actually want is the finished thing that they know works. So how do you solve that problem? Well, you solve that problem by building in a lot of automation and testing and all the rest of it. I think another difference is that the way software is delivered has changed massively. So we no longer ship stuff on CDs. We no longer use exabyte tapes and all the rest of it. Stuff is online. It's software as a service. You can get incremental updates to software instantaneously. As soon as someone wants to release it, you can have it in your hands because you're subscribing to that service. And so because the whole model around software delivery has changed and the way we consume that software, so that the model around how we develop that software has changed as well. Kind of getting back to the kind of why DevOps, that kind of concept of putting things in the hands of users very, very frequently exposes one of the issues, which is that you can't have humans involved, essentially. So it has to be automated. We have to have this very fast cycle time. And if you have people pushing buttons or reviewing things, that's where errors creep in. It's just not physically possible. And so a big driver around DevOps is automating the hell out of everything. Automate all the things, people like to say. And that implies, every place where it's possible. So testing, deployment, or at least running tests, deployment, user experience, those sorts of things. And that quest for automation is ongoing. So people want to automate more and more, take more and more of the kind of possibility of user error out of the equation and just focus on the automation side of things. So perhaps it's interesting to explain a little bit about my personal exposure to DevOps, because I wouldn't be involved in this space if I didn't believe in it. I guess a couple of interesting examples. So one, I was involved with a company where we were delivering a software product. And when I joined the company, we had a product. It was composed of a number of different pieces in a number of different technologies. And we had tremendous problems with simply getting that product in the hands of customers in a reliable, repeatable way. So we had the classic sort of symptoms of, someone had done a build on their laptop, the customer picked it up and it was the wrong build, or it had the wrong dependency in, or just the repeatability was a big issue. And then on top of that, the time taken to create a release, and having said a lot of software was online, this particular product was not online. This was a piece of software that you downloaded and you put in the hands of customers, but the same sort of problems apply. The time taken to actually create the pieces to give to customers was just too long, with lots of manual steps in it, and of course then lots of errors crept in, and we had various issues with customers upset because the bug they wanted fixed wasn't fixed, or you can imagine the scenario. So as kind of part of the leadership team there, I changed that process so that it was almost completely automated, the release process of the product. And that involved a number of interesting challenges. You have to be able to build all the different technology parts of the product separately and bring them together. Not everything is you can't build Windows products on an Apple Mac, and you can't build Apple iOS targeted binaries on Windows. So there's some interesting challenges there. We solved all of those, but the net effect was that we were able to do releases much quicker and much more repeatably. So we always could guarantee that the thing we were giving to the customer was the thing that we actually wanted. And that made a big impact on development. So we could actually focus much more on development rather than actually the kind of handle turning of how do we get this release out, which meant we could do more with the resources that we had available. So that was a key sort of part of my DevOps experience. I think another interesting part of that was, although we were putting software in the hands of customers, the infrastructure that we needed to build that software, we needed infrastructure to build that software, and it wasn't the case of just sort of someone's laptop. We're talking sort of servers and all the rest of it. A key part of DevOps is this whole idea of infrastructure as code. So the systems that you use to assemble and run things are managed in the same way that you manage your code. It's in source code control and all the rest of it. And that, again, means that things are repeatable. So, if a truck drives through your office and takes down your server room, you can rebuild it all because it's all in GitHub somewhere or whatever. So that idea that you sort of treat the process like the code was kind of important to our success there, and sort of very formative to my understanding of DevOps. I think going back a bit further, when I was at BEA, DevOps, when I was at BEA, DevOps wasn't really, we were doing DevOps-y type things, but no one was really talking about DevOps like that. One of the key points there was having a way of automating or running tests automatically so that every developer check-in could be verified in some way. And while this wasn't a process I drove, but I was part of the experience of this. While I was there, we went very much from a kind of end-to-end linear process where you would only really find out whether you'd broken things kind of days later, to a process where we could run sort of testing pipelines against individual developer changes, and we wouldn't merge those changes unless the testing pipelines ran. And that was great from a developer productivity point of view, but also great from a delivery point of view, because the worst thing in the world is you commit a change, someone commits a change, and some test breaks several days down the road, and you don't really know. If you knew what had broken it, job done. But generally that's not the case. You have to kind of do git blame or something like that to try and figure out where the problem occurred, and that is tremendously expensive. You start having to do things like stop developers checking in stuff, stop the pipeline. It just brings the whole thing to grinding to a halt. Once it's like once the system is no longer running smoothly, it's basically not running at all. And so this idea that every time a developer checked something in, we knew that tests were not going to break because we'd done that kind of verification up front. That was tremendously powerful, because it just meant we could make guarantees around shipping times. We knew we wouldn't have to have a massive ramp down into the ship, because there were not going to be any gremlins that would come out of the woodwork late on in the process. To dig into it a little bit more, in the old world, when we were very linear about development, the problem was that we found issues late, and finding issues late is very expensive from a kind of figuring out what the problem is, B, fixing it, testing it, all the rest of it. And the classic kind of in software testing, there's this kind of classic QA pyramid where you want a lot of very simple tests run as close to the development process as possible to find the obvious problems. And then on top of that, you want a smaller number of more complicated tests, and then a smaller number of integration tests. And then right at the top, you'll have QA folk doing manual kind of regression testing, or even users, if you want to consider users as testers to some degree. And the whole point of this is to try and catch problems as early as possible, because that's the cheapest and the easiest time to find issues. Once you've started to stitch things together, or if you're developing firmware for embedded systems and you've rolled it out to 1 million devices, that's not a great time to try and find bugs. It becomes tremendously expensive to fix. We can all think of examples. Intel microcode flaws are great examples of very, very expensive bugs to fix, because they were found very late in the process. So you want to find bugs as early as possible, and because development is ongoing, development is continuous, you want to do testing in a similar manner. You want testing to be continuous and ongoing in a similar way. That said, so great, you move all your tests as early in the process as possible, and developers might be happy, but they won't be happy if by moving all the tests early in the process means that they have to wait forever for their changes to get validated. So you want to move, so you still need this pyramid, and you still need later stages to catch more complex scenarios. And you need to do that in a way that it doesn't impact developer productivity, but it also makes sure that the quality of the product is still high. And so, as well as testing going on automatically and continuously as part of the development process, you want testing happening automatically and continuously as part of the kind of end-to-end pipeline of, development through to release, to try and strike that balance between, quality and speed.
That's great, Andy. It's really great to hear your personal experiences and a really thorough overview and impact over the last few years of where DevOps has come from and its inception. I've got some thoughts. If it really is seemingly, the ideal path to follow around DevOps, why do you think Agile is still dominating the conversation over DevOps?
I don't know for certain, but I have some observations. I think one would be that clearly a lot of people are doing what we used to refer to as Wagile, so Agile in a waterfall methodology, so not truly doing Agile, so there's some of that going on. I think also there's been this kind of shift. Earlier on in my career, there was a very distinct delineation between development and QA. So development tended to do development, and then stuff would get handed off to QA for testing. That line has been blurred more and more, and modern development practice advocates things like TDD, coverage-based development, so where you're sort of trying to write tests as part of your development process, being guided by the coverage that you see in your sort of IDE or whatever. All of those things require quite a mental shift for developers. So it requires discipline, it requires training, it requires education, and people are people. I often with developers that the kind of the adrenaline rush is when something works, right? When you get the thing working, and the sort of most natural thing in the world is to ignore testing in the pursuit of getting something working. And I suppose that the sort of educational change is that actually you can get there quicker if testing becomes part of that process, but a lot of people haven't kind of adopted that. So I think they're kind of beginning to get au fait with Agile, but not, they're sort of reacting against this need for testing to sort of be built into the process.
Cool, thanks, Andy. I think it's interesting your points around how testing might be seen to be taking a backseat against developers when they're doing their software development. I'm wondering if you sort of think about what AI is, taking steps towards automatically writing intelligent tests, or there's already talk of being able to use software to automate testing and support DevOps and developers. But I wonder what your thoughts are around sort of AI being able to go that next level and actually writing intelligent tests.
It's important to separate out the mechanics of running tests and detecting failures versus the process of writing tests. Tests can take a number of different forms. There are tests that you write to verify what you believe is correct behavior and correct operation. There are also tests that you write because, in TDD, you're writing tests when there is no operation. You're sort of writing against implementation that doesn't exist. You come up with a failing test and then you drive your development off the back of it. So I think there's a number of different routes through that problem. I think I see test automation as much more about the mechanics of running tests than the process of writing tests. And mechanizing test running is a relatively easy problem to solve. Automating the writing of tests is a much harder problem, and that's why not many people have done it, and that's why Diffblue are focused on the problem and doing some good stuff there. So, I think everybody would love to automate the writing of tests if they could, but it's a hard problem. That's why it hasn't happened to date.
Thanks, Andy. That's really interesting insight to understand the impact sort of more on a day-to-day level of developer processes. And now, taking a wider view on DevOps, it'd be interesting to hear what you think around the challenges, hurdles, and potential roadblocks that could exist in an organization if they wanted to adopt the DevOps mindset.
DevOps requires some discipline. So there is an upfront investment cost to DevOps, to infrastructure as code, to test automation. You have to invest in technology, you have to invest in process. For instance, you can't, if you're going to automate anything, you have to first figure out what that thing is. So you can't automate a process that you don't understand or don't know. So some companies have challenges with simply understanding what they're doing at the moment, and so automating those kind of aspects is going to be hard unless they can get their hands around that. And I think some of the challenges there also are customers recognize that they're doing things wrong, and so they try and kind of make changes to the process while they're trying to automating stuff, and that never tends to end well. You're better off kind of automating what you have, and then once you have automation and some feedback and ability to figure out whether you're getting better or not, you can then start to make changes. So I think there's some organizational challenges there. I think there's some investment timing challenges as well, because DevOps requires some level of upfront investment. For instance, let's take test automation. There is manual testing at some level is always going to be quicker than writing an automation framework if you don't have that automation framework. So, there's always this challenge that businesses are under the gun to ship products, code, applications, whatever, and sometimes they never get the opportunity to take the time and spend the money that they need to do to kind of pause, get the automation done, and then move on. So I think that's one of the challenges is that delivery is always kind of manana. They're always looking to we'll do it tomorrow because we've just got to ship today, sort of thing. Whereas actually, if you look at the long view, there would be much better place to actually make the investment and then reap the benefits. Yes, there's going to be some delay, some pause initially, but medium term, that's going to pay off massively. Again, that's sort of it's not a technology problem. That's much more of an organizational problem that people have to recognize that these things have costs, and you've got to sort of make strategic decisions about how you're going to spend time and money in order to reap the benefits. I think the onus there is on business leaders to recognize that DevOps requires change, and they need to be supporting and empowering that change. I think you probably wouldn't have to go back very far that business leaders would not have a clue what DevOps even was. Whereas these days, I think that there's a recognition that that's changing. They talk about IT having a kind of seat in the boardroom these days, and that's kind of changing more and more as the kind of process of development and delivery becomes an important part of that sort of IT conversation. So future trends of DevOps. So I think one of the key pieces, well, there's a couple of key pieces. One is people don't necessarily know what good looks like. So, they'll read on Twitter about Skyscanner doing 200 developments a day or whatever, but they just have no clue how to get there. And the expertise required to get there is in high demand and short supply. This is true of IT all over. The really good people are thin on the ground. What's the solution there? Well, one solution is the hope that you can train up many more people to be really good at these things. That generally hasn't worked out too well. What tends to happen is that we use computers to solve the same sort of problems. So we raise the problems to higher levels of abstraction so that more normal people can use those tools or systems or processes or whatever. I mean, compiler is a great example. Writing machine code was actually, or assembler was a very hard thing to do. Compilers came along, written by some really, really smart people, but they came along and raised up to a higher level of abstraction, so to widen the kind of user base, so you didn't have to be a complete expert to write computer code, essentially. So DevOps is the same. I think tools and systems are the key here. That once we know that what good process, practice, technology looks like, how can we automate? How can we automate the automators effectively? And we're seeing that shift happen as we speak. There have been some DevOps companies. I guess I would think of companies like Puppet and Chef and those sorts of companies. I mean, traditionally dealing with configuration management, but getting into the process of how do you put together DevOps pipelines easily in a way that you don't have to be a complete expert to do it. Similarly with, Amazon Code Build, Amazon Code Pipeline, all those sorts of things. It's putting easy-to-use tools that embody best practice in the hands of users who don't have the time to do a PhD in DevOps or whatever. So I think we're going to see that more and more, and I think that's great because it takes. It's great for businesses because it takes a lot of the guesswork out of it. You're not having some expert come along and say, oh, you need this widget and that widget, and I can splice these together, and by the way, it's going to cost you several million quid. In the end, you can sign up for a service from Amazon or whoever and get the same thing for a much lower price point. So I think that's one trend. But the next trend, obviously, is, well, where next? So, that's kind of that's making the mechanical piece easier to consume. But ultimately, with DevOps, we're trying to take people out of the equation where they can be taken out of the equation. Obviously, we want people, developers, coders, to do what they're best at, which is think creatively, develop solutions for user problems, and not getting them doing kind of mechanical work effectively. And AI has a big part to play there, because it's not that AI can think like a human, but AI can be used to sort of more intelligently take some of the sort of grunt work out of those sorts of tasks, and testing is a big part of that. For instance, I think everybody would recognise that there's quite a mechanical aspect to testing. People know what tests, a certain class of tests should look like, what they should do, and ideally they would want a computer to do that for them. But actually, it's one of those problems where it's easy for a human to say, well, this is what it should do, this is how it should work. Much less easy for a computer to do, but not impossible. And so that's I think one of the key shifts, and not just AI, machine learning as well. I know of companies using machine learning to sort of optimize deployment pipelines, to optimize the operational side of things. And so again, it's kind of embodying human behavior in a machine where that's appropriate and makes sense, and where benefit can be realized, and that just frees up developers to do what they're good at, and the great thing about it is that it means that generally development staff are happier because they're focusing on the tasks that they love. And it generally means the businesses are happier because they're removing a lot of the kind of mechanistic, time-consuming parts of the process that can slow things down. So.
Thanks, Andy. It's great to have a few insights around sort of the current landscape of DevOps and the relationship it's got with the wider organisation. Let's say if tomorrow an organisation decided to focus on DevOps, what's the best approach you think they could take, and where can AI sit within this adoption?
Yeah, so key to the how is partly technology and partly culture. So there are some technology changes that could be made to increasing DevOps adoption, but also it's about the business's ability to adopt the process changes that require the mind shift that's required to recognize why it's important, the changes that need to be made. And those pieces are kind of crucially important before you even start looking at AI type solutions. That said, AI can help bridge some of the gap between development and operations, maybe can do some things that otherwise you would never get to in terms of testing automation. As long as AI is kind of low touch, what's not to like about it? You know, if we can add value to developer and developer workflows without increasing their burden, then that can only be a good thing. Over time, AI is going to be the critical piece of DevOps because that's the only way we're going to be able to scale quickly as development organizations. Organizations are always trying to get more value out of their resources, faster ROI and so on. And AI is going to help us do that, improve our coverage, and also does so in a predictable, automated way that doesn't need maintaining, ultimately reduces costs and can improve the security as well. I mentioned earlier that AI is about taking the sort of mechanistic process that humans are currently doing and replacing that with a machine. And the question is, where are you going to get the biggest bang for your buck there? And testing is a big part of that. So everybody recognizes the value of testing. Everybody probably recognizes they don't do enough testing. So how can you get to more testing without increasing overheads or introducing errors or whatever? And this is where Diffblue is great. So we have a product that allows you to write unit tests automatically based on the operation of your software, and that can take out a whole swathe of mechanistic testing that you might otherwise have to do as a developer. Martin Fowler has this famous quote that imperfect tests run frequently are much better than perfect tests that are never written at all. And that there's this kind of sense that developers will, all other things being equal, push tests out to manana if they can, and that never gets the baby washed. So having some kind of testing is always going to be better. It doesn't matter how simplistic it is, at least it is some testing. And that you've sort of got much more knowledge about your exposure, whereas if you don't have enough testing, you have no idea. You have no idea where the bugs are. You know, no idea where problems might be. So we have a product called Cover that allows you to generate tests quickly. You can do that both as part of the development process within IDEs such as IntelliJ, but also in the context of DevOps, we can sort of plug into your development pipeline to generate tests in a kind of batch mode. And to do that on an ongoing basis as code changes over time. The key here is to try and augment the developer. We're never really going to replace the development task, and obviously developers know how their code should work, and so there needs to be some intelligence there, if you will, from the developer. But there's also a huge amount of stuff where you just got to get coverage of your code base. You just got to verify that, not even verify that stuff is working, just verify what you have, essentially, so that if things change and what you have is, it's not necessarily broken in some way. Maybe you've improved things and made things work. But again, the worst scenario is where developers are making code changes, but you just have no way of measuring whether that's making things better or worse, or even worse, it's customers that are finding the issues that are associated with those things. So I think AI has a massive part to play here, and I think everybody recognises that they've just got to get better at the testing part of development, and also the testing part of sort of maintenance of existing products and that sort of thing.
Well, Andy, that's been absolutely superb to hear about all of your expertise and insights around DevOps adoption and the inclusion of AI and why it's so critical around that. For the listeners and viewers at home, if you have any further questions, feel free to reach out to us at info@diffblue.com, or you can find any more information on our website at www.diffblue.com. Again, thanks very much, Andy.